Have you ever worked on any large application where slowly but surely developers start cutting corners? Maybe the core business logic accidentally starts depending on the database, or an interface is not implemented correctly. Over time, this creepy technical debt makes your beautiful clean architecture application tightly coupled or difficult to maintain. What if I told you there is a way to leave your clean architecture application on autopilot and you don't need to rely on endless code reviews? In this video, I'm going to show you how you can write the architectural test and how these architectural tests can be used as a safety net to enforce your application design rules. Welcome back to my channel. My name is Vakas. Today we are diving into a very crucial practice for professional developers called architectural testing. For those of you who are already familiar with the clean architecture, you know the main goal is a separation of concern, keeping the core business logic and the domain layer independent. We use the layers like domain, application, infrastructure, persistence, and presentation. And the critical rule here is that dependencies flow inward. Outer layers can talk to inner layers but never the other way around. How do we enforce this automatically? We use a powerful, lightweight .NET library called NArchTest. It gives us a simple and a fluent way to define architectural rules right inside our unit tests. By the end of this video, you will learn how to write these essential types of architectural tests. Let's get started. Before we write any architectural test, we need to learn what type of architectural rules we can implement. The most common rule in the clean architecture is the layer dependency rule. This rule ensures that the dependencies flow inward. The domain layer should not depend on application, infrastructure, or the presentation. Another rule we can implement using the architectural test is the no direct infrastructure access. Application and domain layers should not reference infrastructure directly. You can also write the architectural test to restrict the framework dependencies. For example, you can write the architecture test to check the domain layer should not depend on any external libraries such as EF Core or ASP.NET Core. Another type of rule is the naming convention rule. You can write the architecture test to enforce the naming patterns for repositories, services, or interfaces. You can also write the architectural rules to make sure that the business logic is encapsulated. These type of checks can make sure that the business rules should reside in the domain layer, not in the controllers or services. You also have a freedom to write the architectural rules that make sure that the interfaces are implemented properly. For example, you can check whether the repositories or the services are implementing the correct interface. You may be thinking that writing these type of complex architectural rules could be a difficult task, but luckily the NetArchTest library make it very easy for us to write the architectural tests. This library has a lot of methods which make it very easy to write the architectural test in a clean and a fluent manner. The core of writing these tests revolves around the static types class. We start by telling the NetArchTest library which part of our application we want to inspect, such as which assembly or project to look at. This can be done using the methods like in assembly. Once we have loaded the types from an assembly, we use the filtering methods like rclasses or interfaces to narrow down our selection further. And finally comes the magical part. We call should or should not methods to apply the specific architectural condition we want to check. I have opened a League Manager application which is built using the clean architecture. Since the architecture tests are automated checks for our code-based structures, we need some sort of unit test projects to run those tests. So let's first create a solution folder in this project and call it tests. Inside this solution folder, I'm going to create a standard unit test project using the XUnit or NUnit library. So let's add a new project in this solution. I'm going to select the XUnit for my test project. Here I can follow that same naming conventions I'm already using in this project, and I can name this project leaguemanager.architecture-tests. Here I can select the .NET 10 as the target framework. Let's quickly rename this default unit test 1 class as architecture tests. As we need to write the architecture test against different layers of the clean architecture, so we need a way to store the references of all these clean architecture layers inside this test class. We can do this by creating some variables here which can hold the reference of all these clean architecture assemblies. Let's create our first private variable that will store the reference of our domain assembly. We can name the variable domain assembly, and here we can specify any type that is available in the domain project. And using that type, we can get the reference of that assembly. The reason I'm getting this error is because I need to make sure that I am using the system.reflection library on top. Now we can copy this line and paste it multiple times, and then I can rename these variables to store the reference of other assemblies. For application assembly, I can specify any type or interface that is declared inside the application layer. Similarly, for the persistence assembly, I can specify any type that is declared inside the persistence project. Once we have the references of the assemblies available, we are ready to write our first architecture test. Simple but very effective rule is to enforce the naming conventions of our classes or interfaces. Let's say we are working on a clean architecture project and we decided that all the persistence classes, specifically the repository classes defined in the persistence project, must end with the word repository. So let's rename this test1 method to make it more easy to understand. In our case, we want to create a rule that all the repositories should end with the word repository. So we can rename this method as repository classes should end with the repository. This makes your test easy to understand and maintainable in the future. Before we start writing the code of our first rule, we need to make sure that we have the NetArchTest library available in this project. So let's download this library from the NuGet package manager. Once the NuGet package manager is open, you need to search for NetArchTest library. And from the search results, you need to select the NetArchTest.rules library and you need to click download. To save over time, I have already written the architectural rule for this test. So let's copy that rule from clipboard. Let me explain you line by line how this rule is working. First, we are loading all the types available in the persistence assembly. Next, we apply the filter using the rClasses method because we are only interested in the classes, not the interfaces. Next, we are using the haveDependencyOn method and we are passing the iRepository interface name inside. This method will make sure that we are only applying these rules on the classes which are implementing the iRepository interface. And finally, once we have the list of all the types filtered, we are using the haveName ending with method that will make sure that all the repository classes are ending with the name repository in them. You can see how easy it is to write the architectural test using the NetArchTest library. We are simply using a fluent syntax to chain multiple methods together, and most of these methods are self-explanatory. Let's run this test and see whether it's passed or not. As you can see, the test is passed because all the repository classes in my persistence project are following the correct naming conventions. Let's see what happens if one of the developers forget to follow the naming conventions. I'm opening the persistence project and inside this place feature folder I have a player repository. Let's say one developer in your team is not following the naming conventions or he forget to provide the correct name by mistake, and instead of providing the repository he provided the name player repo. Now, if you have the architecture test in place, this test will immediately fail and you will be able to catch the developer mistake quickly. Let's run this test again. And now you can see the test is failed. If you open the actual test, you will also see the message that all repository classes should end with the repository. This message is our custom message which we added at the end of this test. Let's go back to the player repository class and correct that mistake. Now your test should pass again. So you can see my test is passed. This test is just an example to show you how to apply the naming conventions. But you can write more architecture tests to enforce the naming conventions or your CQRS commands, queries, handlers, etc. Safeguarding the layer dependencies in the clean architecture is where the architecture test shines most and provides us the most value. In the clean architecture, the domain layer holds our core business logic, and the domain layer should not reference the outside layers such as the application or the infrastructure. If the domain layer accidentally references the application or the infrastructure layer, you break the core principle of the clean architecture. So let's write our next test that will ensure that the domain assembly cannot have any dependency on application assembly. I will once again copy the test I have already written for you. In this test, we are once again scanning all the types in the domain assembly, and we are using the method haveDependencyOn, and in this method we are passing the name of the assembly on which we don't want to have any dependency. So this test will make sure that all the types in the domain assembly should not have any dependency on the league manager.application assembly. You can see how concise it is to implement the layer dependency rules of the clean architecture. Same way, you can also write a similar test that will make sure that all the types in the domain assembly should not have any dependency on the application infrastructure project. If you don't want to write the architecture rules for each one of these assemblies one by one, you can also write one test to ensure that the domain assembly have no dependency on application infrastructure, persistence, or the presentation layer. Let me show you how you can write that type of test. In this test, I have basically replaced the have dependency on method with the have dependency on any method. This method will accept an array of string in which you can pass the names of all the assemblies you don't want any dependency on. So in this case, this test will ensure that the domain assembly have no dependency on application, infrastructure, or the persistence layer. Let's say you want to make sure that all the CQRS queries you are writing in your application are implementing the iQuery interface. You can write a following test to ensure this type of rule. Here we are telling the testing framework to go through all the types available in the application assembly. Next, we are applying a filter using the have name ending with method that will ensure that this rule will only apply on the queries, not the commands. And finally, we are using the implement interface method. This method will make sure that all the types we have filtered so far are implementing the iQuery interface. Now, no developer in your team can write a query without implementing the iQuery interface. And if there is any violation, you will be able to catch that violation long before it becomes the technical debt. Let's say you also want to write a test to make sure that all the commands are implementing the iCommand interface. That test will be more complicated than this simple iQuery test because we have two iCommand interface, not one. If you open the application project and open this abstraction folder, you will see that we have two iCommand interface. One interface will be implemented by the commands which are not returning any response, and the second iCommand interface will be implemented by the commands that are returning some sort of response. So if you want to make sure that all the CQRS commands in your project are either implementing this non-generic interface or this generic interface, you need to write a different type of test. So let me show you how that test will look like. This test is similar to the previous test, but the key part here is that we are using the implement interface twice. First, we are using this for the non-generic iCommand interface, and second time we are using this for the generic iCommand interface. Now, all the commands in your project have to implement one of these interfaces. Let's run all these tests to ensure that all these tests are passed. And you can see all these tests are passed now, which means that we don't have any violation of any architectural rules in our project. Architectural tests are truly an automated safety net for your application. They automate the tedious process of manual code review and catch the serious design violations early. This way, you don't drift too far from the architecture and your application remains scalable. You don't need to wait for the PR review because all the violations will be flagged much earlier during the build process. If you have found this video useful, please hit the like button and subscribe to my channel for more deep dive into software architecture and best practices. Until next time, stay awesome.